So now we're going to be talking about intersection of sets and union of sets. So an intersection of a set, of the set A and B, is called A and B. So this is the intersection, has an and. It's denoted by A and B, so it has like the little upside down U. The way I like to think about that is like they're holding hands. Or like they're bridging the gap between themselves. So it is the set of elements that are members of both A and B. So it gave us kind of some example ones to work with. It's saying, let's write the intersection of U and L. So we are going to write down here, E is intersecting B, or sorry, L, intersects L. And the answer to this one, so we have to just look at which ones are in both of them. We have 0 in both. We have 2 in both. 3, nope, that's only in one. 4, we have that in both. 5, nope, that's just in one. 6, yeah, that's in both. And then 7 and 8, nope, they're not in both. All right, so intersection and union of sets. So, oh, my pen work. Okay, so a union of sets is or. I kind of like to think of that, that we're looking at the vowels, union or. And I like to look at that like there's a hole between these guys. They're not best friends. So if we look at the union between E and L, then the ones that are in only one or, that are in either A or B. So this is very similar to what we talked about yesterday. This has either of them. It doesn't have to be in both. It just has to be true for one of those statements. So basically any number that is in either of those. So it's going to be 0, 1, 2, 3, 4, 5, 6, and 8. So that's all the numbers that's between both of those sets. So next we move on to disjoint sets. So disjoint sets are disjoint if they have nothing in common. All right, they're dissing each other. They're not down with, clowning together. They're not friends. They have nothing in common. So for example, 2, 3, 4, 5, 6, 7. Disjoint because they have no elements in common. Which of the sets up above here, this one, or this one, are disjoint? Now I'm looking at that and I'm saying, all right, L looks like it is 1, 2, 3, 4, 5, 6. E looks like it's just even numbers. O looks like, like it's just odd numbers. So the sets E, that's an E, and O are disjoint. They diss each other. They have no friends in common, not hanging out together. So if we are looking at sets A, B, C from class example number 2, where U was the natural numbers less than 20, it's kind of nice. They don't make us split that. So we are looking at those sets. So now, this is where we kind of have to start remembering some of the words that they've just taught us. So we have, we'll go back for 1 second so you guys can see those. Oh, I moved the, what have I done? Oh no. Oh no. So remember, we have intersection, we have union, and we have disjoint is kind of the 3 things that we're looking at. So this is an intersection, this is a union, and this is a, wait for you guys to really feel like you get it to answer. Yep, Sam, you're right, intersection. All right, so we're going to list the elements of the following sets and describe each set in words. So where are A and B intersecting? Where are they the same? So that's going to be happening. So A and B, we're looking at this one and this one. There's only one number there. that is common for both of them? It is 15. So the union, so the set of natural numbers less than 20. Usually, you guys should write this all out, but I'm just saving some space. That are divisible by 3 and 5. All right. So for the next one, we are doing the union. So what is in either of A or B? So we're going to look at these. So if something shows up twice, like 15, you don't actually write it twice. So this is going to be 3, 5, 6, 9, 10, 12, 15, 18. All right, so this is going to be the set of natural numbers less than 20. And we're just going to change that are divisible by 3 or 5. So now it's asking for A prime, or the numbers that are not in A. All right, so the numbers that are not in A, the opposites of A, but that are also in B. So basically what we can do for this one, we don't actually have to figure out what's in A, in A prime. We can just look at this and we can say, all right, 5, not in both. 10, not in both. 15, that's in A, so it can't be in A prime. So for that one, we're going to have our answer would be 5 and 10. And then this is going to be the set of natural numbers less than 20 that are divisible and this is going to be by 3 that are divisible by 5 and not 3. So now it's saying write a set equivalent to the union between the intersection of B and C. So I'll just erase what I have from my drawings up here. So B and C. Where are B and C intersecting? Intersecting. 6, 12, 15, 5, 10, 15. I don't see any numbers between those two that make sense. So we are going to use our little symbol from the previous page. Who remembers what that symbol is called? Sorry, I didn't put the line through it. Anybody? Anybody want to let me know? Empty set. Good job to whoever answered. All right, so next we're going to do the union, U for union. U for union. The union between A and C. All right, so this is saying A and C. So for this one, it is saying where are A and C matching up and what's in both of them. So for this one, we have all of the numbers that are in C are actually in A. So A is that subset of C. So our answer to this one is actually A, because A has all those numbers in it. We don't need to add anymore. We don't need to write them out again. Now it's asking us about the intersection of A and C. So what numbers are in both A and C? So we are looking at A and C have only those numbers in common. So the answer for this is going to be C. So if D is equal to 2/4, okay, hold on. We'll just end this one and we'll do one more video, my friends. Okay.